Good day, everyone. Welcome to Richfield Hybrid Learning. My name is Silas Toperesu, and I'm your lecturer for Mathematics 512 module. Today, we're going to look at our syllabus topic 2, which is quadratic equations. On the learning objectives of this chapter, upon completion, you'll be able to develop an ability to solve quadratic equation problems using either one of the following method: simple factorization method, completing the square method, as well as using quadratic formula to solve complex problems. You will also be able to develop an ability to solve quadratic equation using graphs. Let's now look at the definition of quadratic equation. A quadratic equation is a trinomial of the form ax squared plus bx plus c is equal to 0, where a is not equal to 0. So any equation will qualify to be a quadratic equation if it have got a variable with the highest power of 2, where the constant attached to it is not equal to 0. Other terms might be 0, but as long as the term or constant that is attached to a variable with the highest power of 2 is not equal to 0, then that equation will qualify to be a quadratic equation. As I mentioned, we have four main ways of solving quadratic equation, such as simple factorization method, completing the square method, using quadratic formula, as well as using graphing method. Many students are grappling with the question of why do we have so many methods on our disposal to solve quadratic equation. This is because some methods will not work for all equations. So you need to choose the right method that will work for any particular problem that you are solving at any time. The other reason is because some methods are much easier to solve using a particular method than other method. So you need to choose the right method that is easier than to choose the complex one when you are solving any quadratic equation. The other reason is that variety is the spice of life. So it's better to have a freedom of choice than not. Let's now look at our first method of solving quadratic equations, which is simple factorization. Simple factorization is typically one of the easiest and quickest way to solve quadratic equation. However, not all quadratic equation can be solved using factorization. This means that factorization is not work for all quadratic equation. In other quadratic equation where simple factorization is not working, we need to choose other method other than simple factorization. Here is an example of solving quadratic equation using simple factorization method. On this question saying solve x squared minus 2x minus 24 is equals to 0. So to apply simple factorization method on this quadratic equation, we need to look for two factors that if we multiply those two factors, they give us minus 24. And if we add those two factors, we get minus 2, which is the middle term on my quadratic equation. So when we look for those two factors, we're only going to find out that only plus 2 and minus 6 are the only two factors. When we multiply them, they give us minus 24. If we say 4 times minus 6, we're going to get minus 24. If we say 4 plus minus 6, we're going to get minus 2. So 4 and minus 6 are the only two factors that if I multiply, they give you minus 24. If we multiply, we add them, they'll give you us minus 2. So now we replace this quadratic equation with the factors of x plus 4, which is our first factor, and our second factor, which is x minus 20 minus 6. Our minus 6 is our second factor. Then we equate this to equal to 0. Then now we split it and say x plus 4 is equal to 0, or x minus 6 is equal to 0. We solve for x. So when we solve for x on the first one, plus 4 is going to jump the equal sign to the other side, and when 4 jumps the equal sign, is going to change the status, and it's going to be minus 4. So we end up having x is equal to 0 minus 4, which reduced to the x value of minus 4. The second one, we have got x minus 6 is equal to 0. So minus 6 jumps the equal sign to the other side, and when it jumps the equal sign to the other side, is going to be a positive. We end up having x is equal to 0 plus 6, which reduced to x is equal to 6. So the solutions of this quadratic equation is the values of x, which is minus 4 and 6. So when you look on the second example, that is also saying solve for x squared minus 8x plus 11 is equal to 0. So when we try to apply simple factorization on this equation, we look for two factors when we that when we multiply them, they'll give us a plus 11, and when we add them, they'll give us minus 8. But in this instance, we don't have any two factors that if we multiply them we get plus 11, and if we add them get minus 8. So in this situation, we don't have any factors. We can't solve this quadratic equation using simple factorization method. We need to look for another method that we can use to solve for the values of x in this quadratic equation. This equation we call it a prime quadratic equation. Let's now look at another example of solving quadratic equation using simple factorization method. Here we have the question that is saying, what are the solutions to the quadratic x squared minus 2x minus 48 is equals to 0? So when we are solving this quadratic using simple factorization, we need to look for two factors that if we multiply them, we're going to get minus 48. And if we add them, we're going to get the middle term, which is minus 2. So when you look for those two factors, we're going to find out that it's only 6 and minus 8. That these two factors, when we multiply them and say 6 times minus 8, we're going to get minus 48. And if we add 6 plus minus 8, we're going to get minus 2. So now we need to replace this quadratic with the multiple of these two factors. So when we're putting the multiple of these two factors, we're going to say x minus 8 because our factor have got a negative. So we're saying 8x minus 8. And the second one, we're saying x plus 6 because 6 have got a positive. So now we've got the multiple of our factors, then we equate it to 0. Now we split these factors solving for x. We're going to say x minus 8 is equals to 0, or x plus 6 is equals to 0. When 8 jumps to the other side, is going to be a positive. So we end up having x is equal to 0 plus 8, which gives us the value of x as 8. The second one here, we have got x plus 6 is equal to 0. 6 is going to jump the equal sign to the other side, and we end up having x is equal to 0 minus 6, which reduces to the value of x as minus 6. So the solution of this quadratic equation using simple factorization is x is equal to 8 and x is equal to minus 6. Here is the third example of solving quadratic equation using simple factorization. So we have the question that is saying, solve the following quadratic equation, which is 5 over 8m squared plus m minus half is equals to 0. So when you are solving an equation in a fraction like this, we need to eliminate the fraction. So when you are eliminating the fraction, we have to look for the highest common multiple denominator of each and every term here. So when you look for the highest common multiple denominator, is only the highest common multiple denominator is 8. So we multiply each and every term by that highest common multiple denominator. So when you say 8 times 5 over 8m squared, you're going to get 5m squared. And when you say 8 times m, we're going to get plus 8m. And when you say minus half times 8, we're going to get minus 4 is equal to 0. So we end up having this quadratic here. So when we have got this quadratic now, if you check on m squared, we have got a term that is more than 1. So every in a situation when we have got a value attached to a variable which is referred to which is more than 1, we need to multiply this with the end constant, which is minus 4 here. So when you say 5m squared times minus 4, we're going to get minus 20m squared. So now when we are looking for factors, we need to look for two factors that if you multiply them, we're going to get minus 20m squared. And if we add those two factors, we're going to get the middle term, which is plus 8. So when you look for those two factors, we're going to find out that it's only minus 2 and 10. That if we would say minus 2 times 10, we're going to get minus 20. And if we say minus 2 plus 10, we're going to get plus 8. So minus 2 and 10 are the only two factors. So once we find those two factors now, we need to return our outer terms, which is 5m squared. And we replace the middle term, we replace the middle term with our factors. So now we return our first term, which is 5m squared here, and in between here we put our factors, which is minus 2, and we attach a variable which is m, and the second factor which is plus 10, and we attach a variable which is m, and then we return also a minus 4 at the end. So minus 4 and 5m squared are returned at the end, and in between we put our factors. And once we have got an expression in this form, we need now to look for a common factor of these first two terms. So if we check on these first two terms, our common factor here is only m. So when you factor out m on these two terms, we're going to get m into 5m minus 2. Then 5m minus 2, it means we need to get also 5m minus 2 when we factor out something on the second two terms here. So we look for what are we going to factor for us to get 5m minus 2. We're going to factor out the common factor, which is 2. So when we factor out 2, we're going to get 5m minus 2. So now we have got our common multiple factors that we have, which is 5m minus 2. So we return 5m 5m minus 2. And the second common multiple factor, it's m plus 2. So we return m plus 2. So now, when we have got these two factors, which is 5m minus 2 and m plus 2 is equal to 0, we equate them is to equal to 0, then we solve for the value of m. When you solve for the value of m, you need to split it. We end up having 5m minus 2 is equal to 0, or m plus 2 is equal to 0. So when you are solving the first one, 5m minus 2 is going to go to the other side of equal sign, and you end up having 5m is equal to 0 plus 2, which reduced to value of m as a as 2 over 5. And the second one, which is m plus 2, 2 is going to go to the other side of equal sign, and you end up having m is equal to 0 minus 2, which reduces the value of m as minus 2. So now our solution for the quadratic equation is the values of m, which is 2 over 5, or m is equal to minus 2 as the solution of this quadratic equation. Now we're looking at the second method of solving quadratic equation, which is by completing the square method. Completing the square method means you convert the quadratic into a standard form of completing the square, which is in the form of a into x minus h to the power 2 plus k is equal to 0, where k, h, and a are constants. So to convert this, you only be able to convert an equation that is in the form of ax squared plus bx plus c 0, which is in the form of quadratic equation, and you convert it in a completing the square standard form for you to be able to solve using this method. So step 1, you need to follow a number of steps when you are solving using completing the square method. So on the step 1, on a quadratic equation, you need to group all the terms that you have got a variable of your quadratic equation. In this instance, we have got the variable of x. So all the terms that you have got the variable of x on the step 1, you group them in one bracket. So when you group this one in one bracket, we need to factor when there is a term that is attached to an x squared, you need to factor that term out, so that we're left with only an x squared, a value x squared here on the as the first one, as the first term. So here when we factor out a, it means even here when the second term we divide by a. So factoring out, it simply means you are dividing. So the first step is to group those you have got terms, and then you factor out if you have got any value on your x that is greater than 1. On step 2, we need to divide the term that is attached to an x. When we divide the term that is attached to an x by 2, we are going to get the results, and that result that you are going to get, we say to the power 2, adding that result in the same bracket and say to the power 2, and we subtract the same result and say to the power 2. So we add and subtract that result in the same bracket. So that is step 2. On step 3, what we added in the bracket, which is the result of divided b over a, we now the one that we are subtracting, we take it outside of the bracket now. But when we take this one outside of the bracket, we need also to multiply it with the term that is outside, which is a, because when a is outside, simply means a is multiplying every term in the bracket. So when we take something out of the bracket, we need also to multiply with the outside term, which is a. So here we are actually taking b over 2a outside the bracket, and when we're taking this one outside the bracket, we're also multiplying it with a. So now we're ending up having in the bracket, we're left with the 3 terms, which is x squared plus b over ax plus b over 2a to the power 2. On our fourth step, we're going to find the perfect square of our trinomial from third step. So when we find the perfect square of our trinomial, we're going to get x plus b over 2a to the power 2 as our perfect square of our trinomial. And we have got these constants that are still remains, which is minus a over b over 2a power 2 plus c. And on step 5, now we're making the perfect square the substitute formula. So for us to left with only x plus b over 2a to the power 2 here, we need to take all other constants to the other side. So when you take all these constants to the other side, they change also the status. C is going to be minus c, and minus a b over 2a to the power 2 is going to be positive. That's how we have got this one on the other side. So when we have got these ones on the other side, we divide by this constant, which is a. So we end up having this, which is b squared over 4a squared minus c over a. So here we are left with our perfect square on the left side. On step 6, we find the square root of both sides. So when we find the square root of both sides, the left side and the right side, we're going to end up having x plus b over 2a. The square root of our perfect square, it gives us x plus b over 2a. And when you say the square root of this one, we're also saying the square root of the right side, which is the square root of this one, where I'm getting plus or minus the square root of this. So now we need to solve for x. So when we're solving for x, when you go to step 7, now we're making x the subject of the formula. When we make x the subject formula, it means we're taking b and 2a to the other side of equal sign. And when b over 2a is jumping the equal sign to the other side, it's going to change also its status. Here we have got a plus, and it's going to be a negative when it jumps the equal sign. So we end up having the values of x as x is equals to minus b over 2a plus or minus the square root of b squared over 4a squared minus c over a. So this becomes our solution of the values of x, and the true solution is the one that is saying minus b over 2a plus this in the square root, and the one that is saying minus b over 2a minus this in the square root. Let's look at one of the examples of solving quadratic equation using completing the square method. So we have the question that is saying solve x squared plus 4x minus 13 is equal to 0 by completing the square method. So the first thing that you have to do, we need to group the ones that have got x variable together. So when you group the one that you've got x variable together, we're going to have x squared plus 4x in one bracket, and minus 13 is outside the bracket. So on step 2, now we need to divide the one that you've got at x, which is 4x. And when you divide the 4x, we're going to get, when you divide 4, we're going to get 2. So when you divide on step 2, we need to add what the result of the division that you divide by 2 here, which is 2. We're going to add it in the same bracket and say 2 to the power 2, and say minus 2 to the power 2. So we add it and subtract it in the same bracket. So when we add it and subtract in the same bracket, on step 3, the one that we subtracted and say minus 2 to the power 2, we need to take it outside the bracket. So when you take this one outside the bracket, we take this one minus 2 to the power 2, we take it 2 to the power 2 is 4. So we're going to take minus 4 outside the bracket. So if we're having another term which is more than 1 here, let's say 2, we're going to say 2 times minus 4 minus 2 to the power 2, then we take it outside. But here we've got only one term, so 1 times this one is not affecting it. So we end up having x squared plus 4x plus 4 in bracket, then minus 4 minus 13 on step 3. So once we have got this one on step 3, we go to step 4. Step 4, now we can combine this minus 4 and minus 13 is equal to 0. Then we get minus 17. On step 4, we find this perfect square of our trinomial, which is x squared plus 4x plus a plus c plus 4, which means the factor of this one, which is the perfect square, is x plus 2. So x plus 2 is the perfect square of a trinomial. So if you say x plus 2 to the power 2 and so expand this one, it's going to take you back to x squared plus 4x plus 4. That's why we are saying this one is the perfect square of this one. So once you get the perfect square, replace this one with the perfect square to the power 2, then we say minus 17 is equal to 0. Now we make it perfect square the subject of the formula. We take minus 17 to the other side. So when you take minus 17 to the other side, it's going to be a positive. So we end up having x plus 2 to the power 2 is equal to 17. And now we find the square root of both sides. So the square root of our perfect square, which is x plus 2 to the power 2, the square root is x plus 2. And also the square root, when we find the square root of this left side, we need also to find the square root of the right side. And the square root of the right side is going to be plus or minus the square root of 17. So now we make x the subject of the formula. When we make x the subject of the formula, we're going to get x is equal to minus 2 plus the square root of 17, or x is equal to minus 2 minus the square root of 17 as our solution. Now we're looking at our third method of solving quadratic equation, which is solving by quadratic formula. This is another technique of solving quadratic equation using quadratic formula. The formula is derived from the completing the square method. The all quadratic equation can be written in the form of ax squared plus bx plus c is equal to 0. So you can solve any equation or any quadratic equation that is in the form of ax squared plus bx plus c using quadratic formula method. So when you are solving using quadratic formula method, you need to identify the constant, which is your a, your b, and your c, where your a is a constant that is attached to an x squared, and your b is a constant that is attached to a variable with x, and then the constant that is not attached to any variable, which is your c. The quadratic formula method that we are going to apply to solve all the quadratic equation that is in the form of ax squared plus bx plus c is equal to 0 is in the form of x is equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. So we need to identify our constant a, which is attached to a x squared, and our b, which is attached to an x, and then our c, which is a constant. Then once you identify those terms in our quadratic equation, we now substitute into this formula and get the solution of our x values. Let's look at this example to see how to solve quadratic equation using quadratic formula method. The question here is saying solve 11n squared minus 9n is equals to 1 by quadratic formula. So the first thing, we need to rewrite this equation in the form of ax plus bx plus c is equals to 0. So when you rewrite it, we are going to have 11n squared minus 9n minus 1. 1 we take it to the other side and it's going to be a negative 1. Then we equate equal to 0. So now identify our constant. A constant a that is attached to an n squared, and a constant b that is attached to an n, which is minus 9, which is our b, and then a constant that is not attached to any variable, which is our c, which is minus 1. Then once we get all these constants, which is a, b, and c, we now substitute them into the quadratic formula equation that is saying minus b, which is minus value of b, which is minus 9, minus 9 is going to be a positive 9, plus or minus the square root of b. B is minus 9 squared minus 4a, 8, 11, ac, which is c is minus 1, divided by 2a, which is 2 times 11. So now when you substituted our values, we're now solving these terms that are in the square root. We'll end up having 9 plus or minus 9 to the power 2 is 81. Then minus 4 times 11 times minus 1 is going to give us 44. So we end up having 81 plus 44, which gives us 125. So now we have got 9 plus or minus the square root of 125 divided by 22, which reduced to 9 plus or minus 5 to the square root of 5 over 22. Let's look at another example for solving quadratic equations using quadratic formula. We have the question that is saying solve 1 over 8x squared plus x minus 5 over 2 is equal to 0 by the quadratic formula. So we can either choose to eliminate the fraction, or we can substitute these fractions exactly. We can identify this fraction as our first term of a, and b as 1, and c as minus 5 minus 2. But to make life easier for us, we can eliminate the fraction by multiplying each and every term with the highest common multiple denominator, which is 8. So when we multiply the first term by 8, we're going to get x squared, and when we multiply x by 8, we're going to have 8x, and when we multiply minus 5 over 2 by 8, we're going to get minus 20 is equals to 0. After getting this quadratic now, which is not having fraction anymore, we identify our terms for a, and then b, which is 8, and then our c, which is minus 20. Now we substitute these terms in our quadratic formula, which is saying minus b, which is minus 8, plus or minus the square root of b squared, which is 8, minus 4a, which is 1, c, which is minus 20, all over 2a, which is 1. So after substituting, we're going to solve it and getting minus 8 plus or minus 64 plus 8 over 2, which reduces to minus 8 plus or minus the square root of 144. Square root of 144 is 12. We end up having minus 8 plus or minus 12 divided by 2, which reduces to minus 20 over 2, or 4 over 2. And our final result, or final solution of the values of x are minus 10 and 2. The fourth method of solving quadratic equation is by using the graphical method. So when you are using the graphical method, it's very important for us to know some of the properties of the graph before we try or attempt to draw that graph. So the graph of a quadratic equation is in the form of a parabola. So when you have got the graph of a parabola, we need also to calculate the vertex of that graph. The vertex is the lowest or the highest turning point of the parabola. Also, we need to know about the property of the axis of symmetry, which is the line that divides our vertex in the middle of the parabola. So those are some of the properties that we need to know about our graph before we attempt to draw it. We also need to find the x-intercept and the y-intercepts of our graph. So to find the x-intercept of our graph, which is parabola, we need to let y is equal to 0 and solve for x values. Or to find the y-intercept of the parabola, we need to let x is equal to 0 and solve for y values. The characteristic of a quadratic graph or parabola is as follows. if the quadratic equation is written in the standard form of y is equals to ax squared plus bx plus c, the parabola opens up the graph. The graph will be opening up, and it means it will be having a turning point vertex at the bottom. So the graph will be opening up when a is greater than 0. A, which is the value that is attached to an x squared. So whenever we have got a value of a attached to an x squared greater than 0, then automatically we have to know that our graph is opening up. So when we have got a value of a attached to our x squared less than 0, then our graph will know that it opened down. So also the x coordinate of the vertex is found by the formula, which is saying minus b over 2a. So whenever we want to calculate the coordinates of our vertex, we simply use the formula that is saying minus b over 2a. We identify our b and substitute into this formula, and then we identify our a, then we solve for x coordinate. And then when we want the y coordinate, we substitute the x coordinate, a vertex value, into our equation, quadratic equation, and solve for y value. Then we get the coordinate of our vertex. Let's look at one of the examples for solving quadratic equation using graphical method. The question here is saying solve the equation y is equals to x squared minus 4 using graph. To answer this question, we can use the method of finding the random values of x and substitute into our equation to find the coordinates that we are going to use to plot our graph. So in this instance, let's let x is equals to 2. So when we let x is equals to 2, we substitute the value of x as 2 in our quadratic equation and find and calculate the value of y. So when we substitute 2, we're going to get 2 times 2 to the power 2 minus 4, and get the value of y as 4. So now we've got one of the coordinates, which is 2, 4, and then we let our value of x is equals to 1 is our random value again. Then we substitute 1 inside the equation in place of x. Then we're solving for the value of y. When we solve, we're going to substitute and get 2 times 1 to the power 2 minus 4, and we get the value of y is minus 2. And now we've got our second coordinate, which is 1 minus 2. We let also x is equal to 0 for us to find the y-intercept where our graph crosses the y-axis. So we substitute in place of x, we substitute 0, and when we substitute and solve for the value of y, you are going to get 2 times 0 to the power 2 minus 4, and we get this value of y is minus 4. And now we've got the coordinate, the third coordinate, which is 0 minus 4, where the graph crosses the y-axis. We do that again and look for another coordinate for x. Let's say now we substitute minus 1 in our equation. We solve with minus 1. When we substitute the value of minus 1, we're going to get the value of y as minus 2. And when we look for another coordinate again and substitute minus 2 in place of x and solve for the value of y, we're going to get 4. Now we have these coordinates. We can go now and plot these coordinates on our graph. Now we're plotting these coordinates on the graph. When we're plotting this graph, we start with the first one, which is 2, 4. 2 is the x value and 4 is the y value. So for 2x value, we are coming here and looking for 2 units going on the positive side, which 1, 2, and then going up 4 units, which is going up 4 units. So 2, 4 is this coordinate, which is here. Then we plot the other one, which is 1 minus 2, which is 1 on the x side, and minus 2 is the y value going down, which is this coordinate. Then the third one, which is 0 minus 4. 0 minus 4, minus 4 is the y coordinate, which is down here, and the x value is 0. And then we plot the third one, which is a minus 1 minus 2, which is we go to the left side of x-axis for the point of 1 minus 1, which is minus 1, and the y value is minus 2 going down, which is this point, which is here. And then the last one, which is minus 2, 4, we go on the left side of x-axis, which is minus 2 units, and then go up 4 units for y, which is this point. So once we plot our points, now we need to draw the curve of the graph that will join all this point that we plotted on our graph. And this graph that we're going to come up with is our graph of the equation of y is equal to 2x squared minus 4. And then now to find the solution of our equation, the solution of our equation is the values of x where our graph crosses the x-axis. So this is the solution of our graph, which is the solution of our quadratic equation. So this point and this point approximate the values where the graph is crossing the x-axis. So the graph is crossing the x-axis here on approximately minus 1,5, and also crosses here on approximately 1,5. So our approximate solution of values of x is minus 1,4 and 1,4. Here is a second example of solving quadratic equation using graphical method. The question is saying solve the equation y is equals to minus 2x squared plus 4x plus 5 using a graph. To answer this question, if we check on our first value that is attached to an x squared here, is the value minus 2 is less than 1. So when the value attached to an x squared is less than 1, it means our graph is opening going down, which means our graph have got a turning point at an upper position. So now we identify our a, which is minus 2, and we identify our b, which is 4, to calculate the vertex point of x where the graph is turning, where we've got a turning point. We substitute into the vertex formula, that is saying minus b divided by 2 times a. So minus b, which is 4 divided by 2 times minus 2, will give us the value of x as 1, which is of our vertex coordinate of x. So to calculate the vertex coordinate of y, we substitute the vertex coordinate of x in our quadratic equation, and we're going to get the value of y is 7. So the vertex or turning point of our vertex is 1, 7. So now we let also x is equals to 3 as a random value of our x. So when we substitute 3 in our equation, we're going to get a value of y is minus 2 times 3 squared plus 4 times 3 plus 5 is equals to minus 1. So now we have also another coordinate, which is 3 minus 1, 3 minus 1. Then we let also x is equals to 2, and when you substitute 2 in our quadratic equation, we're going to get minus 2 times 2 to the power 2 plus 4 times 2 plus 5. Then we get the value of y is 5. Now we have got also another coordinate, which is 2, 5. And then we let also x is equal to 0 for us to find the y-intercept where the graph crosses the y-axis. And when we substitute 0 in our quadratic, we're going to get minus 2 times 0 to the power 2 plus 4 times 0 plus 5, and we get the value of y is 5. Now we've also 0, 5. And we do the same and also let x is equal to minus 1. When we substitute minus 1 in the quadratic equation, we're going to get the value of y is minus 1. And once we have got this coordinate, now we can go and plot them on our graph. Now we're plotting the graph. Since we have got our coordinates, we start by 3 minus 1. So 3 minus 1 is 3 units going on the positive side of x-axis, which is 1, 2, 3, and going down minus 1, which is this point 3 minus 1. Then the second coordinate, which is 2, 5, which is 2 on the positive side of x-axis, 2 units, and then go up 5 units, which is this coordinate, which is here. And the third, which is 1, 7. 1, 7 also it's on the right side with positive of x-axis, which is 1 unit, and then 7 units going up, which is our turning point, which is here, this coordinate. And then we plot another one, which is 0, 5. 0, 5 is the point where our graph crosses the y-axis, which means our coordinate of x is 0, and this is the point where the graph crosses the y-axis, which is 0, 5. And then the other coordinate, which is minus 1, minus 1. Minus 1 on our axis on the left side, which is the minus 1 units going on the left side, and also minus 1 for y going down, which is this coordinate, which is here. So once we plotted our coordinates, we're now joining these coordinates using a line, and this is a curve that is joining all the coordinates. And this graph that we're coming up with is the graph of y is equals to minus 2 x squared plus 4x plus 5. And now once we have got our graph, now we need to look for a solution. A solution is where our graph crosses the x-axis, and this is the point where our graph crosses the x-axis. So we now approximate the points on where the graph crosses the x-axis as our solution of x. So our solution of x on where the graph crosses the x-axis, it's where x is equals to minus 0,85 or 2,8. So these are our approximate solution of our quadratic equations. Here are some exercises to test your knowledge and understanding. Solve these quadratic equations by using any of the method of solving quadratic equation, such as simple factorization, completing the square method, quadratic formula, as well as by drawing the graph. Now we come to the end of our chapter 2 for quadratic equation lecture. Thank you all for being part of Richfield Hybrid Learning Program. I hope to see you all in our next lecture.